This tutorial is all about the effect of particle size of a solid on the rate of reaction. Many chemical reactions involve the reaction of a solid with a solution, and as you can see here, if the same amount of solid is broken up into smaller pieces, there is an increase in the surface area of the solid. Many more particles are now available to react with a solution, and therefore you'd expect the rate of reaction to increase. At foundation level, you need to be able to recall that the rate of reaction will be increased if you use a powder rather than a lump or lumps of a solid, and also be able to explain this in terms of what's called the reacting particle model. A typical chemical reaction to illustrate this used in schools would be the reaction of dilute hydrochloric acid with marble chips. We would repeat the same experiment using the same volume of the same concentration of hydrochloric acid, but each time using smaller and smaller marble chips, or even powdered marble chips, and seeing how the rate of reaction changes. We can follow the rate of this reaction either by the rate at which the carbon dioxide is made by collecting it in a gas syringe, or in this case by putting the reacting mixture on top of a balance and noting that the mass of the mixture will decrease as the carbon dioxide escapes. And if we were doing this on a balance, then we would, for example, do it twice, once with large marble chips and once with small marble chips or with powder, and compare the rate at which various masses of carbon dioxide gas are lost over time. Then we might draw a graph of the time taken to lose various masses of gas, and our lines might look like, for example, this for the large chips, and for example this for the small chips. Difference being that the small chips have a faster rate of reaction than the large chips, but they should still make the same volume of gas because they're using the same volume of the same concentration of hydrochloric acid. This is assuming, of course, that the chips are in excess. We can illustrate this using a diagram. You can imagine the green particles here as being those of the calcium carbonate or marble chip, and in a single chip you can see that most of the particles are inside the chip and therefore can't collide with the acid, the red particles around the outside. That means that the reaction here will be slow because the frequency of successful collisions will be quite low. However, if we break the same number of particles up into a powder, then there are very many more particles of solid on the surface. The acid can therefore collide with more of those, and the frequency of successful collisions is much increased. And that means that there will be a faster rate of reaction. Here's a past paper question. Hilary and Jeff investigate the reaction between marble chips and hydrochloric acid. Carbon dioxide is given off during the reaction. Look at the apparatus they use. Well, they've got the marble chips in hydrochloric acid in a conical flask on top of a balance which reads initially 200 grams. Hilary and Jeff measure the total mass of the flask and reaction mixture every minute. Now, as we can see in the results table, as the time increases, so the total mass of the flask decreases from the initial 200 grams down to 198.8, at which point it stops decreasing, so the reaction appears to have finished at 5 minutes. The total mass of the flask and the reaction mixture at the start is 200 grams. Write down the total mass of the flask and reaction mixture after 3 minutes. Well, after 3 minutes, if we read off the table, that would be 199.00 grams. And use this answer to work out the total mass of the carbon dioxide given off after those 3 minutes. Well, the only difference is that the carbon dioxide has been lost, so that would be 200 take away 199, which is 1.00 grams. Hilary and Jeff do the experiment again. They use the same volume of acid and the same amount of marble chips, but this time they use powdered marble chips. After each measurement, they work out the total mass of the carbon dioxide given off, and look at the graph. It shows the results from both experiments, and I think we can see that with the large marble chips, the reaction is relatively slow, whereas with the powdered marble chips, a steeper graph, and therefore the reaction is faster, although both of them produce the same mass of carbon dioxide in grams, 1.2 grams. It says, look at the line for the powdered marble chips. How long does it take the reaction to finish? Well, let's read down from where it levels off as accurately as I reasonably can. I reckon about 2.9 minutes. The reaction using powdered marble chips is faster than the reaction using large chips. How can you tell from the two lines? The powdered one, or the powdered curve, is steeper. And explain why the reaction is faster using powdered marble chips. Use ideas about particles. I would say here that the surface area of the powder is larger, so there are more frequent successful collisions. And just confirming the answers, the 1 gram from the table, the answer in the range of 2.8 to 3.0, I made it around 2.9 minutes. That the powdered chip curve is steeper, or has a higher gradient, and that the powder has a larger surface area, so you've got more collisions, or more frequent collisions, or more chance of collisions. Finally, on the specification, you must know that explosions are fast reactions and involve large volume of gaseous products, and also appreciate the dangers of powders, particularly in industry. So, explosives are substances that burn very, very fast. They don't usually even need oxygen from the air to burn. They normally contain the oxygen in the form of the chemicals which are reacting, called oxidizing agents. And also explosives make large volumes of gas when they burn, and these create the shockwave which does damage to people and buildings, more so than the flames which come from the explosion. If you look on the internet, you'll find plenty of references to custard powder factory explosion in 1981, where the Bird's custard factory in Banbury blew its roof off in 81 due to the powder, which is a combustible custard powder, catching fire and exploding. Other powders which are also combustible, such as sulfur and flour, are also dangerous, and they can all ignite explosively just with a spark. If you search on YouTube, you'll find plenty of examples of custard powder bombs, flour bombs, and so on and so forth. Don't do that at home.